Everyone, this is problem 63 of Neetcode 150, K closest point to origin. So we are going to be given a 2D array, just like this, with the x and y axis. And we are going to be given also the x and y coordinates of a couple points. And we have to render the kth closest points to the origin, okay? So let's say that we have these points here in this graph, and each cubes, so this is one cube, this is two cubes, this is three cubes, represents one unit. So you can see that this point has a x coordinate of 3 and a y coordinate of 2. All right. We can see that the point in the second quadrant here has a x coordinate of 1 and a y coordinate of 4. So 1, minus 1, 4. And the points here at the bottom has a length or x value of -1 and a y value of -1 as well. So I hope you remember this formula from your high school math: a squared plus b squared equals c squared. Okay, the Pythagorean theorem. So this is exactly what we're going to be willing to use, because basically when we say find the closest element, we mean that elements where the distance here is actually the shortest between its point to the origin. Okay, so we are going to use the Pythagorean theorem here to find this, because we're given x and y. X and y here, it's a and b, right? So that's what we are going to do. And after this, how can we do this? Well, we can actually first, what we can do is to sort it, and then just take all the elements at the end from the array. This is one option that you can do. But in this problem, we are going to use a more efficient way. We're going to use a min heap. So we are just going to have to pop the values at the top of the min heap until we have the k value that we want, because let's say the k here is 2. Okay. Well, what you are going to have to render is basically this point here, because you can see it has a distance of 1. And if we do some quick maths here, well, this gonna have a distance of 13, right? So 3 squared plus 2 squared, and this is gonna have a distance of 17. So we will have to render this point as well. So these 2 points is what we are gonna have to render. All right, and we are gonna have to render them in an array. So we're gonna have to render like -1, -1, and also 3 and 2. Whoop. All right. So now that we know the logic, let's go ahead and start coding this. So first of all, we are going to have to create an array. But in this array, we don't only have the x and y coordinates, we also want to have the distance. So let's call this the min heap. Okay, so like this. And now we are going to be willing to retrieve the x and y values in the array points that we're given. So we're going to say for x, y in points. And we're going to create the distance. So the distance is basically going to be x squared. So you can just use 2 stars in Python to do that. And we're going to have to add y squared too. So like this. And actually, it is not super important whether we square it or not, because, for example, if you have a distance that is 9 before the square root, and you have a distance that is 4 before the square root, well, you know that by squaring the both values, the 4 won't magically be longer than the 9. So it is not really important here. But because we don't really want to have the exact distance, we want to have a relative distance compared to the other ones. So if we know that something before, or a value the value of the distance before the square root is greater than the value of the distance of another point, we know that that distance is farther away, so that's good enough. And after this, what we are going to do with our distance, our x and our y, we are going to append them to our the new array that we just created, min e. So min e that append, and we are going to create a structure like this where we have first the distance, and then we have our x and then our y. So this is what we're going to store in the min e. So I hope it makes sense up to here. I don't think I went too far yet. So next step that we want to do, once we have our min e, which actually equals the distance, we are going to create the actual min e, right? Because now we have the min e array, but we don't have the actual structure, the binary tree of that min e. So we are going to create that binary tree by using the collections eq. And in eq, we can call eepify, which is going to actually create the entire binary tree following the structure of a min e for us, so we don't have to handle all the heavy logic behind this, which is great. And what we want, what are the values we want to put in our min e, or we want to basically create a min e with, is basically the array that we call min e. So it might be confusing that I call this array min e as well, but let's just make sure that we understand that min e here refers to an array where we have where each value has distance, x and y values, and this is an actual min e in the sense that this is going to create us a binary tree where all the parents values are actually lower than their child's values. So we know that the smallest value is going to be at the top, and whenever we pop from that tree, we know that the new top value is also going to be the smallest value of that tree. So knowing that we are actually willing to retrieve the kth closest point, so the kth smallest distance, it makes sense that we use a min heap for this operation. So once we have this, we can create our output. This is going to be important because we have to render an array with all the x and y distances, right? So how we will proceed to actually append the top values of the min e inside the output array, I will use a while loop while k is greater than 0, and every time I will decrement k by 1. So this is how we are going to ensure that we have exactly k amount of x and y coordinates representing the closest points to the origin inside our output array. So first, we are going to extract all the values inside the thing that we're going to pop out of the min e, and that thing that we're going to pop out contains a distance, an x and a y. Okay, quite important. So we are going to use again our eq collections, and within our eq collections, we are going to use the epop method. So this is actually going to pop the top element, which is the lowest value in the entire tree, and we have to ensure that we specify we want to pop from the min e the min e tree. Okay, just like this. And after this, we are going to append to the output. We are going to append basically x and y. We no longer need the distance. This was just a temporary variable to solve the problems. And after this, we are going to decrement k by 1, ensuring that we are going to stop the while loop when we have exactly k amount of values inside our output array. Once this is done, we can return output, and the entire job should be completed. So we first found the distance for each point, and then we created a min e for all these distances, and we basically took k amount of values from that min e to append to our output array, and we return this output array. All right, so just like this, we solved the problem. I hope you learned from this video, and I hope to see you in the next one.